an organization. If not, that makes it sad. And if you would like to present, let me know. We're wide open for the rest of the year. So we need presentations. Come to you guys. So, and that's all I got. So good.
Hi, my name is Gwen. I'm a developer and consultant at a company called Island 3. I work on launch fishes. And a little bit of background about me and why I got interested in programming paradigms. So I started learning the program a long time, not really a long time ago, maybe like 10 years ago. And I did some compile languages and MATLAB, but I wanted to get into web and mobile. So a couple years ago, I got into JavaScript, and I thought I was really good. And I started learning frameworks and Node and everything, until I got hired and had to write professional code, pull requests to open source, which turned out really bad. And I didn't even know what the reviewer was saying. And I was telling me why my pull request didn't merge. So I started Googling how should I write good code, and eventually I got semi-addicted to learning about programming paradigms. So that's why I'm interested. So I really like this quote, kind of off the bottom, but by Robert C. Martin, who wrote a really good book called Clean Code. And he said the ratio of time spent reading code versus writing is well over 10 to 1. And then he goes on to argue that it might be 100 or 1,000 to 1. So that's why I think it's important to really plan out and figure out how you're going to organize your code and maybe what's the best paradigm or the best way to write your code for whatever you're going to build. So what is a paradigm? A paradigm exists outside of programming too. It's just a model. So you can think of things we encounter every day, like the scientific method, maybe not every day, but first they come up with a hypothesis and then they have to test it, and there's a certain pattern to it. Or you can think of like cooking or diets are also paradigms. In relation to programming, people use it because it's a certain system that they use for code organization, reusability, testing, memory, especially maybe for mobile. So it can. This topic can get really, I guess, computer sciencey and really into some academia stuff. So I think that's why a lot of people are scared of this topic. But I'm going to try to just talk about specifically how it's applied in JavaScript and not get too much into things like that. So JavaScript is a multi-paradigm language, meaning it's not opinionated about how you want to write your code. These are the three main paradigms, but you'll find others if you're Googling. But mostly you'll find these three, and especially now in functional programming. And JavaScript's really flexible, so you can kind of pick or you can even mix the paradigms. I've been seeing more object-oriented code written in a functional way, for example. So I'm just going to go over like what each three of these and maybe some use cases that where you might want to use it. So for imperative, it's the easiest one. It's exactly how it looks. It's line-by-line execution from top to bottom, synchronous code. It's probably best suited for build scripts, or bash scripts or whatever. If you start writing like something small, then there's no reason to overcomplicate it and think, oh, I have to make this crazy paradigm so everyone thinks that it doesn't make sense for small projects, and this is usually how people start to write. But as it scales, it's really easy to make mistakes. Everything's exposed. There's very little error checking. It's hard to maintain and debug, and it can get really out of control after a while. So that's where people came up with other paradigms so they could organize their code better. So the more popular one now is functional programming. It's kind of a new big hype in JavaScript, but it's not really new because it came about, I think, in mathematics in the 40s, and then the 50s and 60s it was introduced into computer science. There were some reasons why it didn't catch on too popular. It wasn't too popular right away. but in JavaScript, it's just recently become more popular. So here are some of the characteristics of functional programming: composition, mutability, pure functions, recursion. So if you don't know what any of these are, then we're just going to go step by step through each one and why they might be advantageous to use. So pure functions is one of the main concepts in functional programming. Basically, it's a function that takes an input, like the top function. It takes a val, it does some kind of calculation, and it returns an output, and it doesn't touch anything outside of its scope. So in the second example, it's an impure function. It's updating the global variable x, and it's also logging something out. So with a pure function, you can always expect to have the same output if you have the same input to the function. Nothing else is getting updated outside of the function. And that's basically what a side effect is, something happening with the function updating something outside of its own lexical scope. This is probably something you're already using in JavaScript. It's just an important concept for functional programming. It's just a function that takes another function as its parameter. So, so this is in a lot of built-in functions like map, filter, reduce, sort in JavaScript. And then if you use jQuery, it uses this paradigm too. Yeah, so that's pretty simple. And another quote by Robert Martin. First rule of functions is that they should be small. And he argues for, I think, a whole chapter in the book that you should take functions and make them into the smallest composable parts, and then just name them very well. And that would be easy to read code and easy to read programs. So with this, it's part of functional programming. So function composition is just composing multiple functions together. So the two functions sum and mult, you can compose together in a few different ways. So you can either directly do it and just pass the return value of mult in as the first argument of the sum function, for example. Or you can create a utility and do basically the same thing, but just pass in all three values at the same time. So if you're creating a library and you're wanting to use some functional concepts, then you might want to think about, like, oh, how is my user going to use these functions? Will they be able to compose it together? Should I make it more composable, or should I make a utility that does that for them? This is kind of goes along with pure functions. This code is actually from Redux. If you haven't used Redux, it really doesn't matter. This is just the state of the application. It's just an object. And if you want to update it, you can call a function, pass the current state, and you pass an action object. You want to update the name to Coral, and you return a new object. So it doesn't mutate the current state, but it returns a new state. You didn't know what the destruction was. It's the same as like object.assign. So you're not changing this current object. This isn't changed at all. You're just returning a new one, and then it just overwrites the name. So you can also do this outside of libraries. JavaScript has been adding more and more things that allow you to program more functionally. So you probably already know what const is. It's basically sets a variable to a constant. So if you try to point it to a different variable, it's going to throw error if you're in strict mode. Otherwise, it's just and then the problem, or I guess it's not really a problem, but what happens is that const is only a point. It only increases the pointing to the object. So you can still, if it's an array or an object, then you can still update individual items inside. So they also added object.freeze into JavaScript, where you can freeze the whole array, like the whole object. But then you can update individual items, but that's permanent. So it could cause a problem like if you have some really large array or something. You want to set it to null after you use it, but you can't do that because it's frozen forever. So they also have where you can just set it read only if you can maybe I want to change this later. So you can it's kind of weird. You can set any property to be read only, and then you can set it to be writable later. So it will only throw an error as long as it's read only. So here's an example of, I guess, why mutating state could be useful. Again, this is a Redux example, but there's other tools that do things like this too. So this is basic to do that. You add to-dos to the state. You can subtract them to the state, but you're never mutating state. You're just returning a new state each time. So you can do something called time traveling, which is basically scrubbing back and forth through state. The bar at the bottom is just showing it scrubbing back and forth because we made a copy at every single point. So it's really easy to debug if you've ever used like something like Redux dev tools. And you can just step back through and see maybe where you screwed up or what the data was at any point. Another cool thing that you can do if you're using pure functions, or functions where you know that it's not depending on any value from outside of your own scope, you can cache things. So if you have some kind of expensive function, maybe it has like a lot of math or it takes more than 3 to 10 seconds or something to run, then and you can just save the values. So when you get the same input again, you can already have the output saved. You know, so I thought this was really cool. So I made an example. You wouldn't be caching this in local storage. You'd probably be like saving it to an array or something. So this is a number I'm passing in. By the way, this function just does nothing. It just iterates and adds randomly. So it's a bit different, but it just takes a long time. So I'm going to update this first number in case I haven't had it in storage. So it took, I don't know if you can see it here, but it took like about 5 seconds, 4.929 seconds to run that script. But if we try to run it again, yeah, it took like 145 milliseconds this time. So as long as it's a pure function, you can do it like that. You can probably save it to like an array object or something that counts as the storage. And they have libraries for this, but it's a really simple function to do this. And another fun thing that I think a lot of people don't really know how to use recursion. So basically, what recursion is a function that calls itself from inside of itself, which might sound like a weird concept, but a lot of people use it for complicated iterative code. Like if you have that does all kinds of crazy things, it can be written much more elegant in a recursive function sometimes. So people use it for that. And in JavaScript recently, this was optimized so it doesn't add on to the call stack if you return that function. So JavaScript is smart now, and it realizes that, hey, it's just calling itself. So I'm not going to do up the call stack with that. This is an example of it not optimized, so we'll add on the call stack. This is actually part of the So not optimized, but if you're only running it like a couple times or so, you have some kind of stopping point, and it probably doesn't really matter. Closures. So, I think this would be so a closure is just a function that remembers the scope of an outer function. So I'm just going to make one more variable. So if you call, or you're setting var add equal to this inner function here, and you're already setting a equal to 10, and x is 2 from the outer scope. So now whenever you call add, these two variables are already set, and you just need to pass in b. So even if maybe there was no more reference in your code to some closure function, then it still wouldn't get garbage collected because the inner function still has a reference to that scope. So, and this is really used, I think mostly this is used for like returning a public API. So if you had some, maybe some like inner functions and some things you want to expose, some things you don't, so you could just return an object with all the functions or whatever that you want to expose. And then it would remember the whole scope of what the outer function. So, and I think it's using modular code. So some advantages that have been proposed for using functional. I don't know if this is so much an issue in JavaScript being multi-core friendly, but that's one reason why there's been a big push for functional programming recently, to just use pure functions. And, yeah, it's pretty easy to test if you can already expect that your functions will be the same. It's not dependent on global things. There's no weird cases. And you're trying to compose functions and make them as small as you possibly can, then the assertions will probably be easier. So a lot of people are functional programming purists, but it's really hard to have an application with no side effects. Especially in JavaScript, because you're going to be updating the DOM, or you're going to be doing something if you're working on JavaScript. So I would say as long as you're maybe updating the DOM in as few places as possible, but then maybe at the end, there's just no reason to really think about being extremely functional, but it is a good paradigm. It's good to learn all the different design patterns because it can help you. Yeah, and I found that now that I try to write pure functions, it's made my life easier when I'm writing tests, and I feel like I write less errors. These are historical problems of functional programming. You use more memory. They've optimized some of this in JavaScript, like with the call stack. Memory is a lot cheaper. It's a lot more of it now, so it's not so much of an issue. which is one reason why it's recently become a lot more popular. So a lot of people that, or I guess a lot of newer people that have talked about it, think it's really difficult to learn. And I think part of that is because there's terms like coding, functor, and monad, and things like that sound very academic and very complicated. So I think the terms are more complicated than the actual concepts maybe. But it can be intimidating. So for object-oriented programming, this is it's basically created as a way to model code into supposedly real-life problems. And some people argue with that statement that that was the intention of object-oriented programming, and it's used a lot, especially in really large code bases. And it can help with code organization and maybe saving memory. I think that's why I see it so much in mobile gaming, which I'm trying to build mobile games also. Some people argue that JavaScript is one of the few, or one of the only truly object-oriented programming languages. I don't know about every language, but pretty much everything in JavaScript, except for primitives, are objects. These are objects, and functions are objects in JavaScript, so it does use kind of a different paradigm than most other object-oriented programming, because it doesn't use classical inheritance. So these are three main, I guess, concepts that we went into in object-oriented programming. Inheritance is an object. It basically inherits methods or whatever from a parent object. So in JavaScript, or in most languages, it would be a class and it would actually inherit from a parent, but in JavaScript, it doesn't really inherit, it just uses the prototype. So there's like a prototype chain. If you haven't, it's a really good read on NVM or Mr. documentation. It's kind of complicated. So encapsulation is just referring to closing all the functionalities of an object together. And polymorphism is a practice of designing objects to share behaviors and also being able to override. So if the parent has certain methods on it, you can use them in the children, but you can also override them. Which isn't technically overridden in JavaScript because they'll just use the closest prototype to that object. That sounds. So here's an example of inheritance, or just object-oriented programming in general. So here's the constructor function. And constructors, I guess the pattern or design pattern that people use is to capitalize it in constructor functions and pass it whatever properties you want and make them public. And then if you want to share, like if you're going to create children from this or other constructors from this constructor, you can put methods on the prototype that you can use in children. So get area. And then a square, which everyone already knows is a special type of rectangle. You can set the prototype to the rectangle prototype, so then you'll have access to anything on the rectangle prototype. Does that make sense? So if you call the area on either the square or the rectangle, well, square doesn't have its own get area function either on the object or on its own prototype. So since its parent prototype is a rectangle, it then looks like a rectangle prototype. I believe at the end it explains this really well. It looks at the rectangle's prototype and then uses that function. This will continue going up. So that's basically how inheritance works. in JavaScript, not exactly the same, because it just needs to go off a certain prototype chain. And I've heard some people recommend that you shouldn't try to go up more than 2 in JavaScript, and I haven't seen more than 2, so maybe if you have a special use case, but you can go up as far as you want. And then what JavaScript recently did was add classes, which is basically the syntax sugar over what it's already doing. So it's not doing anything new, it's not using classical inheritance, which is the exact same thing from the last example. And the rectangle and square inherits from the rectangle. So the exact same thing, different syntax. Some people might think it's clear, some people say that it's abstracting away what it's really doing. So, oh yeah. So for mobile games, I don't know if anyone's used Phaser.js before. It's kind of an object-oriented library for JavaScript to build mobile games with. This is actually a tutorial game that I made. Oh, you can't see the guy shooting. So he's moving around shooting, but there's so many bullets that you have to constantly create and really box frame. So this wouldn't really make sense on mobile if you didn't have some kind of inheritance. So you can create all these bullets and share the same properties from the same constructor. So
Like, can you make that window? Can you make that window smaller?
yeah.
I don't know if it's more projector or. There we go. It's perfect.
No longer blown up.
Too late. Okay. All right.
Yeah, I haven't quite finished that. Not yet. But I'm building another game. So here's the tutorial is called Basics. That wasn't mine. So we basically have a main file where you set up the game state and initialize everything. And I'm just putting in all these files. Very basic. For the bullets, so create a bullet and use the prototype. So this is a constructor function. So anything on the prototype here is shared between all the bullets that are created. So yeah, you can see the bullets. And here, this is organized in an object way. It's just basically one big object with a bunch of methods on it. Usually I pull these into separate files. But you can create all the bullets you want, and then you need to move the bullets that they go off screen because it's created from the constructor. It saves a lot of memory. That's basically it. So even though there are different paradigms, object-oriented works well with functional, and you can use a lot of, like if you're organizing your code in an object-oriented way, you can still use most of the functional design patterns. So like you could write impure functions in your object-oriented method, but there are some frameworks kind of mixing these now. Specifically, maybe they're in React, but I'm sure other ones too. So I read a lot of React, and they came out and said, if you've ever written it before, they use a lot of inheritance. So they have the new CS6 syntax for the classes that you create and inherit. So I used to just write all classes because I would connect functional components to that's anyway, so it's just easy to do that. But now they're adding in some functional components, so they already did actually, and they came out and said that they're going to give a performance boost. And 9 other reasons why you should start using as many stateless functional components as you can. So I just put a link to maybe why probably using that. And then in Angular, you can add modules. So if you wanted to organize your code in the same way, you could do Angular Bacon, which is functional, and or this is a NPM module. If you wanted to do an object-oriented way. So here's some resources that I found really cool. The top book is very good. It's kind of an easy read, but it goes really in depth on JavaScript objects. So it's kind of an easy advanced book. About 24 hours of videos by Stanford. I'm not done with it yet, but it's really good overall paradigms. And the last one is actually a program I'm writing to help gamify and teach people how to projects. So I made a couple of different branches to compare like imperative versus functional and rewriting and stuff. So you can check that out if you want. And then these are some of my favorite people to follow. Rich is a lot of fun to listen to. He talks about functional programming a lot. Coach C. Martin as well. And Kyle Simpson, if you want to know about advanced JavaScript, he said he reads the ECMAScript docs before bed every night. I don't know if that's true, but it sounds like it from listening to him. So. And that's it. There's my contact information. I'm really easy to find. If you Google me, you can find me anywhere. And, yeah, so if you want to give me feedback, get in touch. If you have any questions, let me know.
Yeah, so I think I was kind of wondering when you were doing the recording of the script that you were running and seeing how long everything took to run, what was it exactly that you were doing with your second function that allowed it to catch what had been previously run and allowed it to speed it up?
So let me show you. I was saving the input as kind of the index in focus storage. So the input, with the example, I put in 1,010,000. So I'd save that as the index. Think about like an index of an array. So you have 0, 1, 2 indices, and then the output I'd save as the value. So you want to copy the function.
I'm thinking indexing like SQL where you index a certain field that makes the query and speed up much faster if you use that. Like, am I thinking the wrong kind of index, or this is actually an array index?
This would theoretically be an array.
Okay, an array index.
Wouldn't it be more like an object key and then value?
It's like a dictionary.
Right.
You're all saying the same thing. You're all saying the same thing, I promise.
Well, yeah, but an array,
An array is
an array of that index would imply that you have all the other indexes as well.
It would depend on the input, I guess. If it's a number, then probably an array would not, otherwise it would be an object. I guess if it's an integer. So yeah, an object. Although I don't know if JavaScript would create, I guess it would create like a null value or something for all the other instances before that.
That's what I'm saying.
Yeah, so maybe an object. It's still, I tested it out, it still runs pretty fast. I'm a little biased towards functional programming, but for mobile, I've been having a lot of fun because I can write modular code in both, so I can take, yeah, I can basically use multiple files so they're not too long and important to each other. So I can use some similar design patterns, but I couldn't, yeah, I like composing functions and stuff. Trying to dissect the data and
Are you able to use the version takeoff? You know, just any module and figure out a way to use the version? What percentage are you able to move that way?
So I've been dabbling with Haskell recently, but I haven't found good use cases for using that in JavaScript. I've been trying to, like a couple of utilities I've used version for, but then for promises, like if I only have to do it times, but then I won't have to go on version, I'll just have the function call itself again, so if I have a new version, just go. So, I would love to.
Still looking for more
Yeah.
opportunities.
It's a lot of fun now that I'm thinking about it. It's a lot of fun. And Haskell's a lot of fun too. I think you can use the same data structure, but if you're updating it, I think that's your functional. And you can get a lot of which you're doing it directly as a shallow context. Because I use a lot of Redux and even when you're not having these like similar patterns, so it's like you have a state object. Like it's some, yeah.
They're all together.
They're using SQL. Is that, I use NetSQL sites to pass it. I might have
You could do the same thing. You just take all your classes, remove all the Java out of it, like all your fields, so there's your data structure. Then you would run like whatever the top is to take the process down. That's the way. Yeah.
Functional the same.
Yeah. If you use JSON, you don't have to like traditional objects. So that's why, yes, it doesn't take away data. You still need it. How you organize it is completely up to you. That's all it is. Yeah, it's easy with JSON, but if you're just like a general class instance, something like that, it's a little trickier. So that's why going from an OOP world to functional is also the thing is the one is functional. That's not it's a different way of thinking, trust me. Is it done? Is it done?
So I'm not really a designer. Oh. So basically, I was just this eventually is supposed to match the string and then the sidebar to some points or something. It does some matching. Go there, do. So if you use CSS sushi, I want to use or do a similar thing. Hands on keyboard all the time. I think it teaches you little by little how to do projects. So and there is so this is where I started separating it from the weird messy code finish first. So usually here I would return any function that I wanted to expose. That I've been playing with this new thing. I think part of functional, what's called functional reactive programming using events. So in the resources that I included article. So basically, all these modules are just listening for various events. Like commit ones, and document notes is updating down here. So it emits an event, and then other modules are listening.
All right, guys. Well, that's it. Thanks to Salesforce for hosting us and for please, there are some Salesforces here that talk to them. Otherwise, some of us go next door to Tom's afterwards. If you want to get things off the food. Other than that, yeah, fun.
There's actually my brother who because no one knew what someone was.
She's more interested. It's really I think it's more.
This.
We're actually